Hello boys and girls, welcome to this presentation. Today we're going to talk about the relation of the area, perimeter, and the volume of a shape to the enlargement or the enlargement factor. I'm going to give you an example. For example, if we have a shape like this, which is a square, let's say, and this square has four sides which are equal, or four equal sides. Let's say these sides are 3 centimeters each. Let's say this is 3, okay? So this is 3 centimeters and this is 3 centimeters, and all of them are 3 centimeters. Now, when we talk about enlargement, we're going to talk about scale factor. Let's say that we have a scale factor of 2, okay? Let's say that the scale factor is 2 or positive 2. Now, we have the area, perimeter of this shape. Now, what is the area of this shape? Very good, it's 3 times 3, which is 9 centimeters square. Very good. Now, what is the perimeter of the shape? Very good. The perimeter, you're going to add them all together, so it's 12. So the area is 9 and the perimeter is 12. Very good. Now, if you have a shape like that, and it's going to be enlarged by a scale factor of positive 2, it means it's going to be bigger. Now, what is the perimeter of the new shape? Very good. We take the perimeter of the old shape, we multiply it by 2, we will get the perimeter of the new shape. Very good. Let's say this is the new shape here, in which we multiplied it by 2. So we got sides of 6 centimeters, because 3 times 2 equals 6. Very good. Now, in this example, we understand that when we talk about perimeters, we can multiply the perimeter of the old shape by the scale factor to get the perimeter of the enlarged shape. This is for perimeters. What about area? Is that the same? Now, when we multiply the perimeter, which is 12, of this shape by 2, we get what? The perimeter of this shape, it's 12. We multiply it by 2, we get 24, which is the perimeter of the new shape. 12 plus 12 equals 24. So with perimeters, it's good. We can multiply the perimeter of the old shape to get the perimeter of the new shape, or the circumference of the new shape. Very good. Now, when we talk about area, can we do the same? Very good. We can't. We have to do one step before that. Because the area is squared, we have to multiply the scale factor by itself. So we have to make 2 squared. And then we multiply it by the area to get the area of the new shape. For example, what's the area of this shape? Very good. It's 9. It's 9. And then we multiply 2 by 2, we get 4. So 9 multiplied by 4 equals, very good, 36, in which it's the area of the new shape. 6 by 6. Very good. So we understand here that with the perimeters, we can multiply the perimeter of the old shape to get the perimeter by the factor to get the perimeter of the new shape. But if we're working with the area, we have to double or square the scale factor, and then multiply it by the area of the old shape to get the area of the new shape. For example, let's talk about the perimeter first. The perimeter of this shape is 12. If we multiply it by 2, which is the scale factor, we get 24. And it's the perimeter of the shape. Very good. Now, sorry. But if we're talking about the area of this shape, the old one, is 9. When you multiply it by 2, you don't get 36. So you have to square the scale factor because the area is squared. That's the idea. So 9 times 4, which is squared, this one is squared, equals 36. 36, which is the area of the new shape. This is for the area and the perimeter. What about the volume? When we talk about the volume, for example, let's take a 3D prism or a 3D shape. Let's draw it here, like this. If we have a 3D prism like this, what is the name of this prism or shape? Sorry, solid. What's the name of this solid? Very good, cube. Very good. Now in this cube we have 3 centimeters height, 3 centimeters width, and 3 centimeters length, and we want to enlarge the shape by a scale factor of 2, and then find the volume of the new shape. So the question says, what is the volume of a cube with 3 centimeters length, height, and width enlarged by a scale factor of 2 or a positive 2? So how do you answer this? Because the volume is always cubed, right? The volume is always cubed. So first step we do, we take the cube and put it on the scale factor. Very good. So we take the cube and put it on the scale factor. So 2 cubed is what? It's like 2 times 2 times 2. So we do it like this. We multiply the scale factor by itself 3 times because the volume is cubed, and then take the new number and multiply it by the old volume. For example, what's the volume of this shape? 3 times 3 is 9. 9 times 3 is 27. Very good. So the volume of the cube is 27. And the second step, we take the scale factor, multiply it by itself 3 times because we're talking about volume here, and then multiply the new number by 27. So 2 times 2 is 4, times 2 is 8. And then we multiply 8 by 27 to get the volume of the new shape or the enlarged shape. So to summarize the idea, let me write it here as a summary. If we're talking about perimeters here, if we're talking about perimeter or circumference, we multiply the scale factor by the old perimeter, right? By the old perimeter, no problem, to get the new perimeter. So let's call this the new perimeter. What about area? The new area. If we want the new area, do we do the same? Very good. So what's the first step? Because area is squared, very good. We square the scale factor, very good. So we make the scale factor squared. Sorry about the handwriting. Scale factor will be squared. I just want you to understand this and memorize it at the same time. And then multiply it by, very good, the old area or the area of the small shape. Very good. Now this is for the area. What about the volume? If we're looking for the new volume, what do we do first? Very good. What do we do with the scale factor? Because the volume is cubed, yes, we put the cube or multiply the scale factor by itself Very good. 3 times. Because the volume is cubed. That's it. You just understand the idea that the area is squared, so the scale factor must be squared. And then we multiply it by the old area. The volume is cubed, so the scale factor must be cubed. And then we multiply it by the old value, or the old volume, I'm sorry. That's the idea of getting the new perimeter, new area, new volume for shapes, and depending on the scale factor of enlargement. Very good. Thank you very much for watching. See you next time.